Today we are going to look at SVTs, supraventricular tachycardias, and this is going to provide us not only just a little overview of what we're looking for. In addition to that, we're also going to kind of identify why this is supraventricular, and that there are at least 5 different rhythms that we would have to roll out before we can call something an SVT. So let's start off as we do with every strip, is that we want to identify whether or not it is readable. And again, looking at a readable strip, all we're looking for is to decide whether or not we can identify any waves. And as I look at this EKG strip here, I can see that this is a pretty good readable strip. So my first answer here is going to be, for readable strip, is going to be yes, this is a readable strip. And then I want to know, are there P waves present or absent? So as I take a look at this, I really start taking a look down here, and I can't tell whether or not these kind of waves here, they kind of look like they're pretty big. So as they look like they're pretty big, I'm going to call these T waves. Okay? So I'm calling these T waves because in life, particularly when we look at EKGs, other things in life, but anyway, when we look at EKGs, one of the things that is necessary is that T waves are mandatory and P waves are optional. So P waves are optional. And one of the reasons why we say that is because in a rhythm that is like this, we really can't tell whether or not there is a P wave that is present or absent. So, well, really, I can't see them. So therefore, in this case, we're going to say that they are absent. I really can't tell whether or not there's any P waves that are in here. Okay, so let's get rid of these. So if I'm looking here that there is not a P wave for every QRS, I can't answer that. I can't tell whether or not there's a QRS for every P wave. A PR interval, I can't tell because there's nothing there, as well as being consistent and regular. So therefore, I cannot get an atrial rate at this point because I can't find a P wave, right? I can't find something that looks like a P wave. But what I can do is take a look at my ventricular aspect of things. So here we're going to pull in our calipers. And when I pull in the calipers, we're going to, first off, start taking a look to see whether or not this is regular or irregular. So we're going to go ahead and put my calipers here, and we're going to line these up. Okay, so we line that up, and now I'm going to move this, and we're going to see if this is regular or irregular. And if you notice as I'm moving this, I mean, these are really right on. And this is indicating to me that this is, I don't want to say the word dead, but it is dead regular. I mean, there is no change that I am seeing here. So I'm going to definitely say that this is regular. Okay. And usually what I want to do is this is dead on regular, meaning that there's no R to R variability. Right? So there's no R to R variability like we see with a sinus tachycardia. And so therefore there is that little issue there. Our look at our QRS duration. So we'll bring our calipers back up here. And now we're going to, again, and I think just for this one, we're going to use this side of the calipers. And we're going to just line things up. And when we do that, and I move this, I'm looking at this as being about 1.5 blocks, somewhere in there, about 1.5 blocks. So this is actually going to be a QRS duration here of 0.06, right? So this is a QRS duration that is actually sitting at about 0.06. And when I look at this as being at 0.06, that is telling me that at least I'm following these normal conducting pathways, right? So it is like right there. So our QRS duration is at 0.06. And now we need to take a look at our ventricular rate. And now I'm just going to move my calipers again. And just for this, we'll just, well, it's easier on here. and we should be about 300, right? So I'm sitting here at 6 blocks, right? So here's 300, and then here would be 150. So let's take a look at this again. So if I bring my QRS duration, right? So here's a QRS. Here is where the next QRS is. So as a result of that, when I see this next QRS duration is sitting here, okay, this is actually 6 blocks, okay? So I'm looking at this as being 6 blocks. So if I really wanted to know about this, then I'm going to go ahead and divide this out. We're going to put 1500 inside of the box, and then we're going to divide this by 6, and that actually comes out to 250. My ventricular rate here is at 250. Okay? So, by definition, and as I said earlier, we're going to be calling this an SVT. So what I have found is that I have a dead regular rhythm. I have found that I really can't see a good P wave. I have a narrow QRS complex that is what appears to be following normal conducting pathways, and I have a ventricular rate that is greater, technically, than 160. Right? So anything that has a rate that is going to be greater than 160, I can't identify a P wave. And I'm also going to roll out some other things here. Right? So this is where we start coming in to identify that I've rolled everything else out. I'm going to call this a supraventricular tachycardia. So now here's where I think we get into some of the nuts and bolts of this stuff. So we're going to come back over here, and we're going to look at that heart again. Okay, so I'm going to make this heart right like that. Okay, so we have our heart. And inside there, we're going to come in here. We're going to make sure that we can draw our nodes. So we have our heart. So when we start taking a look at some of these things, we're going to realize that this here, okay, that is going to be the SA node. Then we know that this here is the AV node. And then here is the Purkinje fibers. Okay? Well, one of the things that we need to take a look at here is that the SA node is typically firing at a rate of 60 to 100 times a minute. If it accelerates, as long as there is a P wave, it would end up becoming a sinus tach. So out of this area, we could say that rates that go, and we're just going to put this up here, rates greater than 150 above the ventricles, because it's supraventricular, okay, one of them would be sinus tach. Okay? Well, the problem with sinus tach, or the issue here with sinus tach, is that we would need to see that from that sinus tach, that it is actually, you would see a P wave. So we would have to roll that one out. Sitting up in this area, we also know that there is another rhythm that could generate, and it can go greater than 150, and this would be an atrial fib. So also sitting up in here would be a rhythm, which could be number 2, we could say would also need to be an atrial fib. What we know about atrial fib is that the rate has no P waves, or I'm sorry, the strip has no P waves and also has an irregular rhythm. And in this case, this was a dead regular rhythm. So therefore, we have rolled out sinus tach, we have rolled out atrial fib. So we also need to take a look at another one. Well, let's take a look here at our AV, right? So we said that our AV node, we could have the thing here. This would actually be, this is the junction, right? So we could actually say that we would look for something that would be a junctional tach. And if it is a junctional tach, this usually means then that there is no P waves and that rate goes faster than at 150, right? So that can happen. You can have a junctional tach. But a junctional tach, again, doesn't have a P wave. It's regular and it is narrow. Is there a possibility that this could be a junctional tach? Could be. We're just not 100% sure. Okay, so this junctional tach can be one of those other issues. Okay, I'll move the other ones over here in a minute. So keep in mind, the other things with junctional tachs or any junctional rhythm is that, so usually, so if it goes and it has a narrow QRS complex like this, okay, so it just kind of does one of these. The other thing that it could do is have an inverted P wave and do something like that. Okay, so it could have that inverted P wave. Move those out of the way for right now. The other one that we want to take a look at, though, is we said junctional tach, atrial fib, sinus tach. Something else that also comes out of this AV node, or is actually controlled by the AV node, now is going to also be an A flutter. Okay, an A flutter. Now, an atrial flutter is characterized by having flutter waves and then a QRS complex, and then flutter waves and then a QRS complex. And this continues. So that would be what appears to be an atrial flutter. Atrial flutter has doesn't have a good baseline. And this one has a baseline, and it almost appears that it could be sawtooth. But one of the reasons why we would roll out atrial flutter is probably because we're going really, really fast. So this is a ventricular rate of about 250. So as a result of that, from our standpoint, I'm not a cardiologist, but from our standpoint, we would probably look at this and say, no, this is too fast for an atrial flutter. Okay, so our fourth one that we would take a look here would be the A flutter, right? Okay, so we have the A flutter. So we've covered sinus tach, atrial fib, junctional tach. We looked at atrial flutter. And now we also need to take a look at least one more. Okay, so number 5 is also going to appear somewhere up in here. And this is now going to be, and I kind of blend these all together, this would be an atrial tach. Atrial tachs, consider it being, whether it's a re-entry tachycardia. So this is where we're putting all these things in here. So it could be re-entry. It could also end up being a multifocal atrial tach, or it could just be a straight atrial tach. We're going to blend all those things together into that atrial tach. And with an atrial tach, you usually see a P wave. And here we do not see a P wave. So that is why we are moving that away. And this means that when we have rolled out the sinus tach, the atrial fib, the junctional tach, the atrial flutter, and the atrial tach, we have no other choice but to generic it and call it an SVT. So by definition, it means supra. So supra is higher. Okay, supra meaning higher than the ventricles. Okay, higher than the ventricles, and it's fast, so it's a tachy. And so that's why we call it a supraventricular tachycardia. It's above the ventricles. And I think that's probably about where we need to stop at this point. We're not going to get into a whole lot of the treatment that relates to this, and we can make another one that is actually taking a look at when you get into a VTAC. Is it a VTAC versus an SVT with an aberrant conduction? A little bit beyond where we're at right now, but this is looking at the basics. So keep in mind that you want to apply the rolls, and when you apply the rolls to these EKGs, you usually are right. So have a good one.